Hello everyone. Today we'll start our first lecture on the chapter set theory. My name is Obisek Bhattacharya. Okay, let's start the chapter. Now, first we see that what is a set theory. Now, set theory or a set is means that a collection of anything, like anything, means any material, any numbers, any objects, any letter, any alphabets, etc. So, in this lecture, it is a math class, so we will describe here about the numbers, integers, natural numbers, rational numbers, etc. So next we go to the representation of a set. We represent a set within a second bracket. Now now all the things that we written in the second bracket, that is called as each of an element. See an example first. So see this first, that is here, that this one is an element. Clear? This 2 is also an element. This 3 is also an element. Clear? Now, the basically we represent set as a two type of representation. First is the roster form, and next slide we'll describe about the set builder form. Now, this is the representation of the roster form. I hope this slide is being clear. Next slide, we go to the next slide. On the second slide, we see that there is a set builder notation or set builder form of representation of a set. Now, it also be written in a second bracket. Now, first we see in the second bracket, that is x. This x, sorry, wait a minute. This x is the represent all the numbers. Clear? Okay. This sign represent the belongs to. This sign represent belongs to. This n is a set of natural number. Will come here from on the next on the future or next slide. Now this sign is called as the such that. This dotted sign is called as such that. This dotted sign is the such that. Now on the next part, we see that x is greater than 0 and less than 11. Also, x is an odd number. This is called as general property of all the numbers in the set. This set In this stage we will discuss about what type of set is that, like x is a odd number, or x is a even number, or x is a prime number, or x is a natural number, like this. In this part we represent that range of the x, means from where and from to where the x is belongs to. Clear? Okay. I hope this notation is clear. We'll go to the next slide. This is very important notation. In future we will discuss about this very importantly and in the various question. Clear? Okay. Now see some example first. Now see this example. In this example, we can see that a, that is equals to second within the second bracket x, this such that x belongs to n, 0 less than x less than 5, second bracket close, like this. It means that this representation means that, or this statement represent that a is a set of x. A is a set of x such that This sign is such that all the x is a natural numbers this is a set of natural numbers. We'll discuss after this slide. And this x is belongs to 0 to 5, 0 to 5, 0 to 5, sorry, 0 to, sorry, there's a mistake. Okay, now next type of example, see this. The above statement means that B is a set of P by Q such that P and Q P and Q belongs is a integer where Q always not equals to 0. Q always not equals to 0. Clear? Okay. Q always not equals to 0. The above statement means that B is a set of P and Q such that P and Q is a integer where Q not equals to 0. Clear? Sorry, mistake. P by Q. I say that P by P and Q in the here P by Q. Clear? Okay. On the next slide, we see that some special set like N, Q, Z, and R. What is N represent? Capital N. Capital N represent like natural numbers. Capital N represent natural numbers. What is the Q represent? Q's represent set of rational numbers. Like what is means of rational numbers? Means point number. Means 0.2, 0.3, 0.5, 0.6, and so on. The 1.2, 1.3, 1.5, 1.6, and so on. Clear? Okay. What is Z? Z is a set of integer. Z is a set of integer. Z is a set of integer. Clear? Okay. Means it can be negative, it can be positive. Like -2, -3, -56, -3, or +1, +2, +56, +90, etc. Clear? Okay. Now next is that capital R. What is the capital R represent? Capital R represent the real number, set of real number. Set of real number. Now, what is the real number set? Is -2, 0, 1, 1 by 2, 3.14, √2. Clear? If you don't know about the real number, you put the doubt in the comment section. I will see later. I will answer you later. Okay. Next is the important terminology in the of the set. Now, first is the empty set. What is the empty set? This is a set that contains no element. It also called as null set. This also called as null set. Okay. Now we represent a null set by the sign phi. By the sign, this is the sign of phi, and this is a null set. See here, no element is present in the second within the second bracket. Clear? Okay. Next set of terminology is the finite set. This is a set that contains finite number of elements. Means 1, 2, 3, 4, 5 plus complete. Complete. Clear? 1, 2, 3, 4, 5 complete. So this is a finite number. Clear? Next, infinite numbers of set. This is a set that contain infinite number of set element. Sorry, element means infinite. Any end is there. No end is here. Clear? Okay. Now, singleton set. What is a singleton set? It contains only one element. See here, the example is here. See that. Sorry. Okay. So A is equals to, within the second bracket, let's say 2. Clear? So within the second bracket, only one element is present. So this is a singleton set or single set. Clear? Unity set also called. Clear? Also called as unity set. Also called as. Next, equal set. Okay. Now two set are called as equal set if they have same element. Means let's say, just dictate it first. So let's say A is a set where the element name is that within the second bracket 1 2 3, and the second set is that B, that contains 1 2 3. So A and B are called as equal set, that they contain same number of element and same element. Clear? Okay. Now next is that subset. What is the subset? Say an example first. Let's say A is a set that contain within the second bracket 1 2 3, second bracket close, and next set is that B that contains 1 2 5 3 4 9. So in this two set we can see that A is also present in the set B. So A is belongs to set B, then A is a subset of B. That's clear? Okay. Now A, if A is a subset of B, then the symbol of representation is that, like this. This is the symbol of representation. And if A is not a set of B, then A this set of representation. Clear? Okay. Now this is not so important. This two is not so important. Just read, or we will share this PPT presentation in the description box. Clear? Okay. Okay. This this terminology is very important. This terminology is very important. Okay. Okay. Now next, on the next slide, we will discuss two very much important things, that is terminology, that is the union and intersection. These two are very much important terminology. We will discuss about it in the future with many questions. Okay. Okay, now see this union. Now let's say A is equals to 1, comma 2, comma 5 within the second. B is equal to 3, comma 6, comma 9. Clear? If C is equal to the 1, comma 2, comma 3, comma 6, comma 9, then we can say that C is the union of A and B. C is the union of A and B. Means within the second bracket, that all the terms of A and B will present within the C. Clear? All the terms will present in the within the C. Clear? Okay. Now the representation of the C, A, this is the sign, this is the sign of union, this is the sign of union. Okay. And B. Clear? Okay. Now coming to the Venn diagram. This is the block of A. This is the block of B. Two block will intersect in this section. So in the upper statement, we see that C is a set that cover all the element of A and B. So this is the shaded part that will represent the set C, means all the element of A and B. Okay, I hope that is clear. Next terminology is the intersection. What is that intersection? let's take an example. Let's say A is a set that contains 1, 2, 3, 4. This set, clear? And B is that set that contains 3, 4, 5, 7. Intersect means the element that will present also in the set A and also in the set B. Which is the element? 3 and 4. So then the intersection of the A and B is given by A intersect B, that is equals to 3 comma 4. This is the sign of intersection, just opposite to union. Clear? So what is the intersection portion? This is the intersection portion. Clear? This is the intersection portion. This is the intersection portion. Clear? I hope all the slide is clear. If you have any doubt, please put it in the comment section. I will answer your question shortly. Okay, thank you.